Redox reactions involve reduction and oxidation. Let's look at the definition. Well, we'll start by looking at oxidation. Oxidation is the loss of electrons. Here is sodium. It loses one electron to become the sodium ion. So that is oxidation. We say that the sodium is oxidized to sodium ions, and it's a reducing agent. Now, reduction, on the other hand, is a gaining of electrons, and here it is. You can see 2 electrons being gained by fluorine to become the fluoride ion. And we say that fluorine is reduced to the fluoride ions, and it is an oxidizing agent. These are referred to as half equations, but we not normally refer them like that. We write them as a full equation. But here we have to double everything up because we need 2 electrons. So once you do that, you add the left-hand side up and times this whole first half equation by 2. You get 2 sodium atoms there with 1 fluorine and 2 sodium ions from there. And the 2 electrons from here and there cancel each other out. Let's look at simple redox reaction. This is what we call combination reactions. And these are with aluminium combining with oxygen to produce aluminium oxide, magnesium with magnesium chloride forms, and magnesium with sulfur forms iron sulfide. Now let's look at the first. Is aluminium is oxidized to the Al3+ ion, and that's oxidation. The oxygen gains 2 electrons, so it's reduced. So that's the reduction part. So the same thing applies to all these, the other 3. There they are, oxidation on that side for the magnesium and reduction from the chlorine, accepting the 2 electrons become chloride ion. The ion shows oxidation here, and the sulfur is showing the reduction part. Now, examples of other redox reactions is the extraction of metals from their ores. Here 3 ores: iron ore, copper sulfate, copper ore, and the zinc oxide in that ore, and the iron is produced from that ore through a oxidation reduction process, and the same there and there. I won't write the half equations for that. Here is an example of displacement reactions, which is also redox reactions. So here is that if we put a piece of zinc into copper sulfate solution, or a piece of copper dropped into a zinc silver nitrate solution, you get these reactions taking place. A displacement of one metal by another. So the copper accepts 2 electrons from the zinc becomes zinc ions. The copper copper ions here become copper. And here we've got copper giving 2 electrons to become copper ions, and the silver collecting the 2 electrons, silver ions, to become silver. Now we've got an activity series. So if you were to put a silver dropped into zinc sulfate, for example, it won't displace the zinc because the silver is not very reactive. It won't produce 2 electrons to become the silver ions. And if you look at it, it's right down here. So on the activity series, those elements which are up the top here will give up electrons more readily than those down here. So the silver that we said here, putting it into the silver zinc sulfate, would not be very readily giving electrons. But if you put it into a mercury chloride, then it might work. Reactions of metals with hydrochloric acid and dilute. Now these are examples also of redox reactions. And here they are. The zinc loses 2 electrons, become a zinc ion, and the 2 electrons is taken up by the hydrogen ion and in the reduction process, and it's oxidized to hydrogen. The same with the H+ from the acid, collects the electrons that the aluminium releases, and it will become hydrogen gas. Sulfate and the chloride ions don't have any reduction or oxidation capability, so these are spectator ions. Another example is the reaction of a halide with a more reactive halogen. The chlorine oxidizes bromine to bromide, and while bromine oxidizes iodine to iodine. This is an example of oxidation reduction. The CO2 gains 2 electrons from this one, which becomes bromine, and then that becomes a chloride ion once it gains it. Now, bromine, being more reactive, will actually collect 2 electrons from the bromide ion, and it will become will collect 2 electrons from the iodide ion and become iodine, and that one that's an oxidation reduction reaction. Other reactions which involve oxidation reaction are these called the oxyanides: manganate, dichromate, nitrate and sulfate. And here are the examples. That for manganate, these are all reduction reactions, and we will produce these types of ions here on the other side. Okay, now the standard reduction potential, this is the ability here, how high the reduction ability of this to accept electrons it is. So when it accepts electrons, the fiber produces that plus the water. This has got a greater ability than this one, and this one here has got a smaller E0 value and going down to higher. So I've got another table here which shows all the E0 values there, fluorine being the most, and as you can see here, right down the bottom, potassium ions are the least. Hydrogen in the middle here is where it's all standard reference to. So once you know, you can look these up, you can take into account how to work out oxidation reduction reactions given these E0 values. We won't go into too much detail.